our video today, we're talking about changing our scale. Change of scale is another type of transformation, so like our transformations that we've learned about before. Whoa, hello. There we go. Let's try that again. It's another type of transformation, and it's defined by a rule. And we're looking at a change in scale being one of three possibilities, so a dilatation, a stretch, or a compression. In the rest of the video, we're just going to look at examples of each of these, how we can tell when one of these has happened on a graph, how we can tell by looking at the values of a point x and y, and how we write the rule that defines these changes in scale. So we'll start with dilatation. Maps our initial figure, so whatever image you're starting with, onto the image of that figure based on a fixed point. And we call that the center. The image is going to be larger, smaller. It can actually be the same size as the initial figure. And the change in size depends on the scale factor. Okay, our scale factor is a lowercase a. And we can find the center of the dilatation by connecting the edges of the initial figure and its image. So here we have an example of this. This black dotted line along here represents connecting the edges of the initial figure and its image. And we connect it backwards and we find our center. So our center is highlighted here. And that's basically the starting point or the center of our dilatation. For us, we're going to be looking at our dilatation centered around the origin O, sort of like our rotation was centered at the origin O, and having a scale factor of A. A is just going to be a number. Okay? A can be positive, can be negative, can be a decimal or a fraction, it can be any number. And the way we write it is like this. H represents that dilatation around the origin by a scale factor of A. We'll take any point x and y and transform it into a times x and a times y. So how does that value of a change the shape of our object? So how does the scale factor change the appearance of our initial figure? So we'll look at three different possibilities here. If the size of a is between 0 and 1, and I've written this in this way here, that means the absolute value of a, in other words, just the size of a, ignoring a positive or a negative sign, is between 0 and 1. So 0.5 or 0.1, there's going to be a reduction of the initial figure. Okay? And I have these pictures backwards here. Whoops. This is going to be my initial figure. And this is my image. So if my scale factor is small, what ends up happening is that my initial figure A gets reduced in size. It becomes A prime. So when I have my image, when I map my image, it's going to be smaller than the original, okay, than the initial. If A, or the absolute value of A, is equal to 1, the image is congruent, okay? The image is the same size. And that's a good word to stick on your memory aid if you're not sure of what it means right now. If you didn't recognize it when you saw it, you should make sure you have that definition because it does show up a lot in this chapter. We see here two shapes. We have our shape A and our shape A prime, and we can see that they are in fact the exact same size. If the size of A is more than 1, so if the absolute value of A is greater than 1, there's an enlargement of the initial figure, so it becomes bigger. We can see this here with this silly little picture of a tiger. So the original shape is smaller, and our scale factor must be greater than 1 because we see that our image is larger. And now we're going to look at two other cases. And the thing to be aware of is that the three previous cases, so A between 0 and 1, A equal to 1, and the absolute value of A greater than 1, those can all occur with these two possibilities. Okay, that's why we were talking about the absolute value. So if A is positive, if it's greater than 0, if it's a positive number, then the initial figure and the object are located on the same side of the center. So this is my center here. We're using the origin as our center. And we can see here that our object has the corners A, B, and C, and that it's on the same side of the center as its image. So A prime, B prime, and C prime. And that's a clue for us that our value of A is a positive number. So what does it look like if A is a negative number? If A is negative, then our initial figure and its image are located on opposite sides. So this is our center here, the origin, and this is our initial figure, and this is its image. And we can see here that the scale factor a, this lowercase a, is going to be less than 1. Geez, Ms. Ellis, your notes are terrible today. It's less than 0. It's a negative number. So what does that look like? Well, we can see that they're on either opposite sides of the origin here, and that means that our scale factor is a negative number, so it's less than 0. Let's take a look at other types of changes in scale. We're going to look at horizontal stretch and compression. So if our x value of the coordinate is the only value changed by a scale factor, then we have horizontal stretch or compression. So dilatation, we had our x and our y changed by the same scale factor of a. For a horizontal stretch or compression, it's only our value of x that's being changed by a scale factor. And we write this using this rule. So our x and y get transformed into ax and y. We can see that the y value stays the same and that the x has been changed by the scale factor of a. And what we're going to look at now is, same as before, what happens as we change that value of a as it becomes bigger or smaller or negative or positive. So we have a horizontal stretch that's occurring if the value of a is greater than 1. So the absolute value, in other words, just the size of whatever number a is greater than 1. We have our initial figure being stretched out horizontally. So we can see our initial figure here in red. And we can see that all of the y values are still the same, but the x's have been stretched out. So our object ends up being stretched out horizontally. And this is actually x and y being mapped onto 2x and y. So we can actually see this is the change that's happened. Our x has been changed by a scale factor of 2, and our y remains the same. A horizontal compression occurs when our value of a is somewhere between 0 and 1, the absolute value, the size of that number a. So our x and y in this case are getting mapped to 0.5x and y. My value of a is 0.5. It's between 0 and 1. And we can see here that our initial figure is this red triangle. And again, all of the y values are the same, which we expect from our rule. Okay, so all of the y values are the same, but all of our x values are changed by the scale factor, 0.5. If our value of a is a negative number, so if it's less than 0, then the image is also reflected. Okay, so it's going to be a reflection, which we looked at in our last section. And more specifically, it's reflected about the y-axis. So our initial figure here is again in red, and it's been reflected. So we actually have a very similar situation. X and y is getting mapped onto, instead of 0.5x, we have a negative 0.5x. So all of our y values again are the same, but our x values are reflected and multiplied by 0.5. So that's how it changes our image. So we want to be able to recognize that this is not only horizontal compression, it's also a reflection. Now let's take a look at another case. So instead of our x's being changed, what happens if only our y value is changed? So if our y value is the only one changed by a scale factor, then we have a vertical stretch or compression. And we write this using this rule. So an x and a y will get changed into x and ay. A, again, is our scale factor. So let's take a look at what happens as a increases or decreases or is positive or is negative. A vertical stretch is going to happen, same as a horizontal stretch, when the value of a is bigger than 1, so the absolute value of a, the size of a, is bigger than 1. And we can see here that our x values are the same. Okay, so it's at the same value of x, but the y values have been increased. And actually for this one, x and y gets mapped onto x and 2y. So every one of our y values got multiplied by 2. And you can actually double check this here. Initially this was at 3, and the image is at 6. And that's going to work for all of our y values. We have a vertical compression when our value of a is somewhere between 0 and 1, so when it's some fraction or decimal. And in this case, we have x and y getting mapped onto x and, I just walked into my table, oops, x and 0.5y. So we can see that all of the y values are now changed, but all the x's are still the same. So it's still at the same value of x, but instead of being at, I think that's at 5, yeah, negative 5, now it's at a negative 2.5. So we have this vertical compression. Our image is being smushed in, okay? And the last one, if we have a value of a that is also negative, then our image will be reflected. So we're going to have another reflection, but because this is dealing with our y, it's reflected about the x-axis. And I guess I should probably move that out of the way for you guys. So the value of a is negative, if it's less than 0, that our image is reflected about the x-axis. And we can see this here. X and y is getting mapped onto x and negative y. So that's a change just to our y value, and we have a reflection. We could also have a scale factor in there. We could have any value. Right now, the scale factor is a negative 1. And that is just a summary of all of our different types of changes in scale, and we'll look at some different examples next class.